Okay, hey ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 9 notes too. So we're just going to be doing just a part of these notes, and then we'll be finishing up the rest of it on a different day. So I just want to get a start on it, then I'm going to have you guys start on your homework, and you can finish it the next day. So let's take a look at first defining what a prism is. So a prism is a polyhedron with two parallel and congruent bases, and the polyhedron itself is going to be named by the bases. So you take a look at this first one right here. Okay, so that's a triangular prism, and it's called a triangular prism because its bases are triangles. Then you take a look at this next one. This next one's called a rectangular prism. And it's a rectangular prism because its bases are rectangles. A cube is something, it's like a dice, okay? All of the sides are squared, so it has a special name, and that's a cube. This one, for example, is a pentagonal prism because the bases of it are pentagons, as you can see by each of the sides. Then the last one, hexagonal prism, because the bases are hexagon. So we're going to use that idea moving forward. Let's practice drawing them. So first I want to draw a triangular prism. So draw a triangular prism, what I like to do to start off with is I like to draw my triangle. So that's my top. And then the triangle prism, it's going to have sides going down from it. Now I'm drawing in 3 dimensions here. So there's going to be a part going back. So that's also going to be a triangle. Now when you draw it dotted, that tells the person looking at it that that's behind. So we also have a triangular edge that's going down this way. So that right there is a triangular prism. So let's take a look now at a rectangular prism. So we know on top we're going to have a rectangle. And then we're going to have sides coming down from it. So I'm going to have sides coming down on each side. So I can connect. And right now this is 3-dimensional without showing the back side. So we can go ahead and we can also add in our dotted lines so that you can see that back side and know that this is in 3 dimensions. Then drawing a cube. That was my favorite to draw when I was in school. For some reason I would sit and when I would doodle on my math homework, I would doodle cubes. Don't judge. Okay, so then I'm going to go ahead and I'm going to make my cube. Clearly I didn't get enough practice because that is horrible. And then we're going to draw the dotted line. And I want you guys to try drawing these out. It's not a bad thing to practice drawing in 3 dimensions. So that's a cube. Next, let's take a look at drawing a pentagonal prism. So the first thing I'm going to do is I'm going to draw a pentagon. Now a pentagon is a shape with 5 sides. So then it's going to have these sides coming down as well as these sides behind it. Okay, you know what, I'm going to try this over. This is why we do this in pencil, so we can erase. And I'm going to make it a little bit more slanted. So we're going to have this, and I'm going to have it be oblique, which means it's going to be slanted. So I'm going to have it slanting this way. So we're going to kind of see that one, and then we're going to connect to a pentagon down below, which is really hard for me to draw apparently. So this is my very horrible attempt at a pentagonal prism. Okay, so the top should have 5 and the bottom should have 5. So hopefully yours is better than mine. We're not going to be doing a whole lot of drawing of these on our homework, thank goodness. So then here we're going to draw a hexagonal prism. So I'm going to go ahead and I'm going to draw out my hexagon, which is surprisingly difficult on the iPad. So I'm going to have 4 sides coming down that I can see. Then back behind I'm going to have a couple more. And so all of these are going to be connecting so that I can get 6 sides on that hexagon on the bottom. So there's your hexagonal prism. So let's take a look at all of these different definitions. So first of all, what is a base? A base is 2 congruent and parallel. That's not working. I should type it. I'll do that next. And parallel sides. Okay, so this right here represents our base, and this right here also represents our base. So 2 congruent and parallel sides. I'm just going to type it from now on. Next, what we have is a lateral face. Well, what is a lateral face? A lateral face are faces that are not the base. So a lateral face is a face that is not the base. Okay, so that's it for lateral face. So go ahead and get that written down. It's a face that is not the base. So an example of a lateral face might be this right here. It's not the base, so that makes it a lateral face. So then what is a lateral edge? The lateral edge is where the lateral faces connect the base. So it's where the lateral faces connect the base. Okay, so I'm going to go ahead and shrink this on down a little bit. I really should learn to type these out in advance. I'm a horrible math teacher. Okay, so we're going to take this. Come on. This is going well for me. Okay, so then let's take a look at base edge. So for base edge, what we want to do next, I'm just going to give up on that, and I'm just going to keep typing below. So for base edge, I'm just going to type them down here. So for base edge, or not, goodness gracious, this is slow. So for base edge, the base edge is where the lateral face connects to the base. So where does that go? So the lateral base edge is where the lateral face connects to the base. So that would be like right here, for example, would be a base edge because that's where it's connecting the base. Next, we want to take a look at the altitude. Sorry. The altitude is where is a perpendicular line to the opposite base. So basically it needs to be perpendicular to each of our bases. So where is that? So if you look here, this line right here is going to be perpendicular to this base and it's going to be perpendicular to this base. Now because this is oblique, because it's being slanted, it's not perpendicular. So what we actually have is an altitude going down this way. Okay, so that right there is going to be perpendicular to the base eventually. So our altitude is more like that. Okay, and I just realized that this one is wrong. Connect not to the base, but to lateral faces. So please excuse my struggle bus right now. It is late and I am tired. Okay, next, let's take a look at this last one, which is a cross section. So a cross section is the cutting either parallel or perpendicular to the base. So what that means is if I were to go on here and I were just to kind of maybe cut out a piece of this, that would be a cross section if I were just to take a little two-dimensional part out of this. So now let's look at what is actually important for today. So hopefully you got some of that vocabulary written down despite my struggles. And that's talking about lateral area. So what is lateral area? Well, lateral area is the sum of the area of the lateral faces. So when we talk about lateral area, we're not talking about the bases. We're actually just talking about these faces that go on the side of the bases but aren't actually on the bases themselves. Okay, so that's the lateral area. So how do we calculate out the lateral area? Well, there's a couple ways. So first way is the lateral area is equal to face A times the height. So taking the area of this times the height, and then B times the height, the length of B, plus C times the height. That's one way of looking at it. Here's another way of looking at it, and that's that the lateral area is equal to the height and then the sum of A, B, and C. And you know what? There's an even easier way after that of looking at it, and that's that the lateral area is equal to the perimeter. So it's going to be the perimeter of the lateral faces times the height. So make a note to yourself that P is going to be equal to the base perimeter. So we're going to look for those base edges like we talked about in the previous problem, and that's what's going to be going around it. Okay, and that's what the perimeter we're going to use. So let's take a look at an example of this. So for number one, what type of prism is it? Well, here's my base, and that base is a triangle. So it is a triangular come on, prism. And how many vertices does it have? So to calculate the number of vertices it has, what we need to do is we need to calculate how many points there are. So there's 1 point here, 1 point here, so that's 1, 2, 3, 4, 5, 6. So there's 6 vertices. How many faces? Well, there's a face here, a face here, a face here, a face here, and a face on the bottom. So I counted that there are 5 faces. Now we want to know how many lateral faces there are. Well, the lateral faces are faces that are not the base. So if we have this as a base and we have this as a base, then there's this shape here, that's a lateral face. This one down here is a lateral face, and this one going up here is a lateral face. So there's 3 lateral faces. How many edges? So we want to count basically how many lines there are on this. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So when I traced it all the edges, I got that there were 9 edges. What is the shape of a cross section that is parallel to the base? So if it's going to be parallel to the base, I'm going to be cutting something out in here. And when I cut it out, it's going to be a rectangle. And now it wants us to find the lateral area of the prism. Well, in order for us to calculate the lateral area, we need to know the perimeter of the base. Well, right now we know 2 sides of our base. So in order to calculate out the perimeter, we need to know the third side to get the perimeter of the base. So I have 6 and I have 5. So I need to use the Pythagorean theorem to get that third side. So I have 6 squared plus 5 squared is equal to x squared. So when you go through and you use the Pythagorean theorem, you end up getting x squared is equal to 61. So then you get that x is equal to 7.8. So the length of that side right there is 7.8. So now the perimeter of this is going to be 7.8 plus 5 plus 6. So that's the perimeter. Now to calculate the area, we need to take the area of the base, the perimeter of the base, which I have here, times the height. So this 7 right here represents the height. If we were to stand our bases on the bottom and on the top, that 7 would represent our height. So right now it's kind of like taking a shampoo bottle and setting it sideways. So it's not standing right side up right now. So 7 is actually our height. So I can take and I can plug this into my calculator exactly how it is. And then I get 131.6, and then it's going to be centimeters, and it is going to be squared because we are talking about a lateral area. Okay, so let's go ahead and let's take a look at this hexagonal prism. Moving on. So talking about a hexagonal prism. So what is the name of this one? It is, like I just said, a hexagonal prism. How do I know that? I know that because there are 2 hexagons as the base. So it's a hexagonal prism. So now I want to calculate how many vertices it has. It has 1, 2, 3, 4, 5, 6 points there, 7, 8, 9, 10, 11, 12 points there. So it has 12 vertices because there's 6 on each base. How many faces? Well, I have 2 bases, and then 1, 2, 3, 4, 5, 6 lateral edges. So that's going to be 8 total faces. Now I talked about the fact that there were 6 lateral faces. So if we were to kind of work our way going around this way, it would be 6. Okay. So then how many edges does it have? So when we're talking about how many edges, we're going to calculate out how many line segments there are. So let's go ahead and let's take a look at this. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 edges on there. And so if we were to go perpendicular to the base and take out a cross section, notice that it would be a rectangle. And I know that's kind of hard to see on the video, so if you're not sure how I'm getting that, please come talk to me and we can take a look at it together, okay? Next, we want to find the lateral area of the rectangular prism. So this is a regular hexagon, which means all of the sides have a length of 5. Okay, so then we're going around and each of these have a length of 5. And 5 and 5 and 5. So really it's just 5 times 6 to get the perimeter when you add all of those together. So our perimeter is 5 for all 6 sides. So I'm going to go ahead and write that out. I forgot how many 5s I wrote, so I'm going to wait for it to catch up. It's being as slow as my brain is today. So then we have that for our perimeter. Now we want to multiply it by our height. Now remember, it's kind of like a tilted shampoo bottle. So the height is actually going to be 12 when we stand it on its end. So it's really going to take all of that, and it's going to end up giving us, so that's going to end up being 30 times 12. And when you multiply 30 times 12, you get 360. And then we're going to write that as centimeters squared. So what I'm going to do is I'm going to actually stop your video here for today. So you're going to start the worksheet and you're just going to focus on up to lateral area on the worksheets. And then we're going to talk about the surface area part on your note video tomorrow. So that concludes it for today. So I'll get you your homework. Thanks for listening.